Welcome to our Spring Boot series. In the last few videos, we used Spring Boot annotations like @component, @REST-controller, and @service. You might be wondering when to use these annotations. In today's video, we're diving into the core annotations provided by Spring @component, @service, @repository, @controller, and @REST-controller. These annotations are fundamental to building robust and well-structured Spring applications. Let's explore when to use each annotation and the special features Spring provides for them. Annotations in Spring are powerful. They act as metadata, providing data about data, and guide the Spring framework in how to treat our classes. They make our code cleaner and more readable by minimizing the explicit configuration that we need to write. @repository, @service, and @controller are all extensions of @component, which means they are technically the same at a fundamental level. However, they differ in terms of usage and functionality. In this part of the tutorial, we will explore these differences to understand when and why you would use each annotation in your Spring Boot application. Let's explore the common ground between @repository, @service, and @controller annotations in Spring Boot. All of these annotations enable Spring to recognize and manage the annotated classes as beans, a process known as component scanning. You can specify the package containing the beans, and Spring will scan and identify all the classes annotated with @component. Since @service, @repository, and @controller are specialized forms of @component, they are automatically included in this scanning process. In other words, @component acts as a general stereotype annotation signifying a Spring-managed bean. Consequently, because @service, @repository, and @controller are annotated with @component, they too are detected and managed by Spring during the component scanning process. Let's start with @component. This annotation is the backbone of Spring's component scan. When you annotate a class with @component, you're telling Spring to manage it as a bean in the application context. It's a generic stereotype for any Spring-managed component. Spring will create and manage the lifecycle of beans annotated with @component. Use @component for your service, utility, or business logic classes that don't fall into more specific categories like @repository or @service. Beyond typical service or utility classes, @component is also used for classes that perform technical, background tasks such as batch processing or database cleaning services. Next, let's talk about @service. This is also a specialized version of @component but is intended for service layer classes. It emphasizes the business logic aspect of the class. It's meant to hold business logic, calculations, and call methods defined in the repository layer or another service layer classes. While @service doesn't provide additional behavior over @component, it's used for indicating service layer and transactional operations. It helps in defining the business logic layer of your application clearly. This layer separates the business logic and data access layers, promoting a clean architecture and facilitating easier unit testing. The @service annotation should be used for classes that encapsulate the core business logic of the application, manage multiple database transactions, or carry out complex calculations, thereby orchestrating the various components of the business layer effectively. Moving on to @repository, this annotation is more than just a marker, it's a specialization of @component that is closely integrated with Spring's data access framework. Designed specifically for data access object (DAO) implementations, it is used to encapsulate storage, retrieval, and search behaviors, effectively emulating a collection of objects. The primary advantage of the @repository annotation over other annotations is its support for automatic exception translation, which converts SQL exceptions into Spring's data access exception. Exception translation refers to the process of converting low-level, often database-specific exceptions into higher, more generic Spring exceptions. This feature simplifies error handling in the data access layer by providing a consistent exception hierarchy that can be managed centrally in Spring applications. Use the @repository annotation for classes that interact with the data source or database, manage transactions, and handle data operations. It is ideally suited for implementing repositories in a domain-driven design (DDD), where it provides a clear and focused role in the persistence layer. By marking a class with @repository, you signal that it's responsible for data access and transformations, aligning with the repository pattern in DDD, which aims to separate the domain and data mapping layers and centralize data access logic. Now, let's talk about @controller. The @controller annotation in Spring MVC marks a class as a web controller, which means it handles web requests and can return web pages. When a web request comes in, the dispatcher servlet figures out which controller to send it to based on the @request mapping annotation or others like @get mapping and @post mapping. While it's mainly used to work with a view resolver for showing web pages (UI), it can also send back data directly if the methods in the controller are marked with @response body. In simpler terms, use @controller when you're building a website that needs to show pages directly to the user, like HTML or JSP files. It's great for any part of your site that needs to be drawn up and sent out by the server itself. Now, let's talk about @REST controller. @REST controller is a specialized version of @controller tailored for building RESTful web services. It automatically treats every method within it as if it's annotated with @response body, which means each method returns a REST response directly, often in the form of JSON or XML. This eliminates the necessity of annotating each handler method with @response body. With @REST controller, the handler methods in the controller class automatically serialize return objects into JSON or XML responses. This annotation streamlines the development of RESTful web services by enabling direct communication of JSON or XML data to the client. Use @REST controller when you are creating RESTful APIs that directly return data to the client, usually as JSON or XML, instead of rendering a view. This is ideal for services that are consumed by other applications or services rather than by direct human interaction through a web browser. So, what's the main difference between @controller and @REST controller? @controller annotation is used in traditional web applications. Here, the server generates HTML pages by rendering views, like JSP files, on the server side before sending them to the client's web browser. This is useful when you want to return a complete web page as a response to the request. In contrast, @REST controller is used for creating RESTful web services. In this case, the server doesn't return a rendered page but rather, it sends back data, usually in JSON or XML format, directly to the client. This is typical in APIs where the client, like a mobile app or another web service, is responsible for rendering the data or processing it in some way. @REST controller combines @controller and @response body, meaning the data returned by each method in the controller is directly written into the response body. To sum it up, the choice between @controller and @REST controller depends on what you are building. If you need to serve web pages, use @controller. If you're building an API that serves data, use @REST controller. This image depicts the three-layer architecture typically used in Spring Boot applications, separating concerns into distinct layers to promote a clean, maintainable, and scalable codebase. Let's start at the top with the presentation/API layer. This is where the action begins. Here, you'll find beans annotated with @controller or @REST controller. Think of these annotations as your gatekeepers, managing HTTP requests from clients. @controller is used when you want to whip up and serve web pages, while @REST controller is your go-to for creating APIs that talk directly with clients in the language of data, usually JSON or XML. Diving one layer deeper, we enter the service layer. Marked with @service annotations, this middleman holds the business logic of your application. It's the brains of the operation, deciding what to do with data coming from the presentation layer and how to engage with the database through the persistent layer. Last but certainly not the bottom in terms of importance, we have the persistent layer. This is where @repository comes into play, interacting directly with your database. It handles all the gritty details of data management, fetching, storing, and searching so that the rest of your application can stay clean and clutter-free. Understanding this architecture is like knowing the blueprint of a building. It helps you to structure your code in a way that keeps it clean and organized, making sure that each piece of your application is exactly where it should be. So, let's build our Spring Boot application right, layer by layer. In conclusion, @component, @repository, @service, and @controller annotations are key to the structure of Spring applications. Use @component for general-purpose components, @repository for data access layers, @service for business logic in the service layer, and @controller for serving HTML pages with server-side rendering. For RESTful web services that communicate using JSON or XML, turn to @REST controller. Each of these annotations is integrated with special Spring features like automatic bean registration, exception translation, transaction management, and aspect-oriented programming, all of which streamline the development process and enhance your application's capabilities. That wraps up our discussion for today. Stay tuned for more exciting topics in our Spring Boot series. Don't forget to like, share, and subscribe for more updates. Happy coding and see you in the next video.